Okay, so welcome everyone. Hello. Welcome to our workshop of today, Build a Multiplayer Real-Time Game with Astra Streaming. I'm Stefano and this is Rugs. Hi Rugs, how are you doing?
Hi, I'm very pumped up to be on a workshop where we're not going to talk about databases, right? It's a change
Yes,
for us.
today it's a
So it's
strange
going to be
thing, but
cool, very
still,
different. Yeah.
it's always data.
But
So
I'm looking
anyway,
forward to it.
okay, so before we start, I would like you to give us a thumbs up if you can hear us clearly, if you can hear me, if you can hear Rugs when we speak, so we know we are good to go. Okay, get some feedback. Sound seems to be good. Okay, great. So let's
Yeah, let us
start.
know if you can't hear us.
No, I think
That's
it's
the
good. I see a
important.
lot of thumbs up, so I think we can
Thumbs up.
start.
Okay.
Very good.
Right.
Okay, so I'll share my screen immediately. And there we go. Okay. So welcome everyone. This is today's workshop by DataStax developers, and in particular, you are seeing me and Rugs. I'm Stefano. I'm a developer advocate. I like Apache Cassandra, but today it's not about Apache Cassandra. And yeah, I like data and whatever you can do with data. So here we are. Rugs, what about you?
Yeah. Raghavan Srinivas, but people have a tough time pronouncing my name, so I just go by Rags. Rags, not to riches, easiest way to remember me. I really am a big fan of distributed systems, and this is where the pub sub mechanism that we are going to talk about today comes into the picture because it's really about decoupling. It's the decoupling pattern in general, right? And you'll see that with the decoupling you can scale independently. And that's kind of the excitement about the workshop today. And you will see that it's a effective pattern to be using in distributed systems, which I'm always a big fan of, and to be able to do it easily and kind of seamlessly.
Yeah.
So thanks for coming.
Yeah. Thank you, Rax. And you said easily, and indeed, easily will be one of the keywords. And wait for it. By the way, here you can see our social handles, so feel free to connect with us. That would be a pleasure. And we will give you more ways to connect with us and with the topics you will be seeing today later. So today you see both of us on screen, but our team is way bigger. You see it's growing and growing, and here is our team. So you see it's distributed as we like the data to be. And yeah, they can be found around in the chat. So there's someone in the YouTube chat. I've seen Alex. Hello, Alex. And somebody else can be reached on Discord, and you will see later how to get in touch with us. We are always happy to help you and discuss and answer your questions, whatnot. Okay, so let's see what's going to happen today. By the way, I've already seen someone asking that, and today's workshop is live, but it will be recorded and it will remain available on YouTube at this link. So if you feel like watching it again later, studying it, dissecting it, whatever, go ahead. That's absolutely feasible. And back to what you see on screen now. Today we are going to stream on YouTube. In case there are some problems with YouTube, we will fall back to Twitch, links in the description. If you have questions or want to discuss or hang out, reach us on the Discord channel mostly, and we will tell you something new on our Discord channel later. During the day, during these 2 hours of workshop, we will be having, a game, even though, today is about building a game and running an interactive real-time game. But games aside, there is also a quiz, a game. And if you participate, you will be able to win some swag, kindly offered to you by DataStax. So it's 2 different games today. Yay, games. Yeah. Okay, so this is all we have to offer, live, interactive, and everything. Now, what are we doing today? We will be starting from a GitHub repository that contains everything for you to start and do what we are doing. So we will be doing together all of the practice with some theory, some explanation, and guide you through the whole architecture of the application we will be running today. But in case you prefer to do it on your own, don't worry, because there is a GitHub repository, and I might already ask our kind Nightbot to drop the link to it. So there is a GitHub repository containing all instructions to do on your own, contains also the slides, and contains indications to homework and exercises. And there is a source code, of course. We will be using Gitpod as an IDE in the cloud. Your link isn't working. Oh, come on, let me try and, oh, wait. Let Nightbot take its time to answer, or maybe I can paste the link. Somehow Nightbot I seem to have done something wrong. So let me paste the link manually. Somebody is asking if this will be available later. Yes, the video will be stored and available later on YouTube. Manieris. Okay.
Oh, so there you go.
Okay. No, this is me. So
here's you, yeah.
Okay, that's strange because I've seen Nightbot working. So okay, no problem.
Keep going. I'll try that out.
So we will be using Gitpod as an IDE because it's very handy. It's an IDE that works in your browser. So you have to install. You don't have to install anything. We just work in the browser. You will see it later. It will work as a Visual Studio Code in your browser. And as far as technology, so backing technology will be basically a messaging system which is built on Pulsar, Apache Pulsar, and it will be offered by Astra Streaming. More on that later. See, now I see Nightbot has answered. So yes, it works. Okay.
It doesn't like you, it likes me.
Yeah, somehow, I don't know why, but no problem.
Yeah.
Okay, so this is, maybe I will, okay, this is, okay, no problem. So we will speak extensively about messaging system and Apache Pulsar and Astra Streaming later. So let me go on. An important thing is that this is an interactive workshop. You will be doing all of the hands-on if you want, but there's more because you might, there are some homework to do for you. And if you do them, and if you submit your homework, you will be able to be awarded a nice badge. There are some collectible badges, one per each of our workshops. And we've seen recently someone who has as many as 10 or more badges. So congratulations, you can start your collection, and these are very nice to, show around to prove you've been attending and did your homework. So today's badge is about event streaming. Okay, so there is another very important piece of information for you. There is a lottery going on. It's called Stacks Giving. It's managed by DataStax developers, and you see the link here. So maybe I can try and ask Nightbot to drop the link. Basically, how does it work? Well, first, what can you win? You can win gift cards, Amazon gift cards from $500 to $250. And how do you enter this lottery? Well, you do some activities that range from posting a tweet about us to building a tiny application, novel application, and submitting that to us. And oh wait, I am in the way, so let me disappear for 1 second. And depending on what kind of submissions you do, you will get more chances to win prizes. So deadline is Thanksgiving, so the 25th, and we will extract winners live on the 8th of December. So please.
I know that most of you come to the workshop for knowledge, but in the process, if I can win something as a developer, why not, right? So try to maximize your chances by attending as many workshops as you can or whatever.
Absolutely. Yes. So, okay. So we mentioned Menti, or better, we mentioned live quiz. We are now about to warm you up with this with this platform we use for the live quiz. And we would ask you, do we need to be present to win? No, I think you don't need to, as long as you submit, and then you will be contacted, because in the submission form, you should give your email to be contacted in case you win. But please try to attend, because it's more fun, right?
Yeah, but I think the drawing is going to be live. So if you're present, so much exciting, right?
Yeah, absolutely. So
although I never win, even when there are only two people.
Yeah.
But still, you can see.
So yeah, there will be a workshop, I guess, on the 8th, on the 12th, and during that we will be drawing the winners. So, but now we ask you to join us on menti.com and enter the code you see in the YouTube chat. Okay, I had some glitch on YouTube, but I think everything is still is working again. Okay. So please go to menti.com and enter the code you see in the chat. Maybe I can switch to your screen, Rags, if it's okay. So you can share your Menti. There you go. So, okay.
You can also scan the QR code. Sorry.
Yes. So I moved you a bit so we can see the people joining. So we will start with a few questions to get to know better, to get to know our audience and to have an idea, who are you? Because we've been introducing ourselves so far. And there will be questions. These are not part of the quiz. They are just to warm you up with the platform. But later there will be a quiz on this platform. So please keep your phone connected to menti.com or your laptop. Keep the page open because later you will be using that to answer the quiz. And these questions are just to know you, but the questions at the end of this workshop will be timed. So the faster, the more points you get, the faster you answer. So first we want to know, where are you from? Just, to have an idea. If you don't need to be so accurate, just, because we know we are a distributed team that speaks about distributed data, and we like to have a distributed audience. And Rax, what do you think? It seems we do.
Very cool. Yeah, we do have somebody from Hawaii, maybe.
Yeah, looks like. Accurate? Okay, so I see some answers on the YouTube chat as well. That's okay, but remember that during the quiz, if you answer on the YouTube chat, that doesn't count. So please, for the answers for the quiz, go to menti.com and enter the code you see on screen. We will be giving that to you later again, because otherwise it doesn't count. So somebody, blackmagic.x is from Milan. Hello, we are very close. Hi.
Elton, you are from Brazil. If you can go in and put in a dot on your map, that'll be great. Yeah, Buenos Aires.
Yes, so Alex is right. What he says in the chat is, when it comes to the quiz, you will not be able to answer in YouTube. I mean, you could answer there, but it will not be counted as an answer for the quiz. So go to Menti.
It looks like America is winning this time, right?
Yes,
we have a lot of people.
Yes.
It's cool. I like it. I'm from Boston, so I'd like to win. Okay. But maybe Europe is winning now. Oh, geez. Look at Europe.
Yeah, Europe. Okay, so India, but also Brazil. Okay, second question. Did you know messaging platforms? So do you know messaging platforms before starting this workshop? Not at all, just a bit, or I'm very experienced.
Ooh, a lot of very experienced folks. Nice.
Oh, Giuliano. Hi, we are very close. Giuliano, this is now, there's a nice surprise because Giuliano, we met in real life many, many years ago because we studied physics together. Hi, Giuliano. Nice to see you. Okay.
He's a theoretical physicist like you as well?
Sorry?
He's a theoretical physicist like you as well?
I remember, yes, should be, if I'm not mistaken. So, Giuliano, were you studying theoretical physics, right? Okay, but let's go ahead. Okay, so we have somebody who is very experienced with messaging platform, kind of. Okay, just a bit, not at all. Very good. So even if you answer not at all, then you are in the right place. But also if you answer just a bit or very experienced, because there's always something to learn.
Yeah, and I think this is kind of what we expected, right? Not at all, quite a few, but some experience, a few, and hopefully, like you said, even the very experienced will pick up a few tips here and there.
Yeah, absolutely. So, are you comfortable with mixed stack with Node.js and Python? All new to me, so I can read code, I can write code, 10x developer. Wow, congratulations to all of you. So all new to me. Okay, so this full disclosure. Today we will be running a mixed stack that involves some Node code and some Python code. But don't worry, because the code is there already in the repo. You can later dissect it and learn from it whatever your level, or maybe improve it. We are happily accepting pull requests to make our code better, right?
Yeah.
You never stop learning. So
yeah,
so
exactly.
No
Even when we are delivering workshops, we pick up a thing or two from the attendees. So
yeah,
so
absolutely.
feel free, to put in, if you think we can do something better, in the chat, whether it's some code or doing things a little differently, feel free to put it in, because this is really about leveling up our skills.
Yeah.
Whether we are a speaker, whether you are experienced 10x dev, whatever.
Yes, and by the way, don't forget that we are still in the lottery time window until Thanksgiving. So if you do some improvement, maybe you can turn it into your submission and get some more chances to win the juicy gift cards. Okay, so have you ever used Apache Pulsar or Astra Streaming before? No? Yes? There's a yes. There are many no's, and I can imagine the reason, because
Perhaps.
yeah, so perhaps you never know.
Yeah.
Okay, so Apache Pulsar is a rather newish kind of messaging platform, and Astra Streaming is very new. It's still in beta, basically, so no wonder. And you're here to see how they work. So welcome. Okay. So I think that was
Quiz time. We can come back later. Yeah.
So we don't close your Menti screen, your Menti phone, whatever, and let's jump back to the slides, because there are some slides for you before we start doing the hands-on part. So there we go. Okay, so let's start. Let's start with some gamers, because today, as you know, we are about to blackmagic.exe. We will try to give answers to your question. What is the purpose of messaging platforms? By the way, when we say messaging platforms, we are not particularly speaking of WhatsApp, Telegram, or stuff like that. We are speaking of backend infrastructure, basically. So you will see more later. Okay, so let's start. If you're here, you want to build a multiplayer real-time game, right? Multiplayer, real-time. I guess the picture that comes to your mind is something like you see here. So there are players connected to different machines, different computers, and they exchange information. They exchange information in most cases through a server, right? So there is some information going from the player, from the client to the server, and vice versa. And this structure is there to ensure the players share the same word. They get the same updates, and they are able to actually interact in a single game field, right? Okay, so far so good. But let's have a closer look at what happens, because clients and server have to communicate. Now, let's say the player on the left is doing something like, I don't know, they are jumping in the game. Probably this information has to go from the client to the server, this big straight purple arrow to the right. But once this information reaches the server, what happens? Well, probably the server will keep this information, stored somewhere or anywhere. But then this has to reach every other client, because they have to be aligned. They have to share this representation of the game word. And how do they do that? Historically, when it came to communications between clients and server, historically, the situation has been for a long time very simple. Clients were asking data to the server was responding with the result. That was it. So this is how databases work, usually. This is how web development has worked for a long time. So client makes a request and waits for a response. But that's probably not satisfactory if we want to start thinking of a real-time game, because it's really not efficient if all clients have to constantly ask the server, are there updates? Are there updates? Are there updates? So this is what is known as polling. And actually for a long time, web development has worked like that. And for a long time, connecting to a database, say, has worked like that. And basically, it's a loop of asking the server and waiting for an answer, then sleeping a bit maybe and asking again, and so on. This is unsatisfactory because it's not really real time in most cases. You have to handle the retry and the looping logic in your application code. There is a waste of resources because every request probably comes with a set of headers. A new connection has to be established all the time, every time. And then think about that. The more frequent you want your request to be, the higher is the likelihood that you are wasting your request, because you will get, it's less and less likely that you will get some actual update if you ask every millisecond. So it's really a hard limit that you are bumping into. So these are the problems with developing a modern real-time application if you rely on the good old polling. Indeed, more modern alternatives have emerged, and we will come to that. So I hope you are now convinced that request and response philosophy is not ideal for what we have in mind. Now, what would be better? Well, I would like my server to be able to push data to the clients as they arrive, maybe on a connection that is kept open for a long time. So maybe the server would be the actor initiating the data push. And you know what? That's exactly what a messaging platform is there for. So messaging platforms will basically be the piece of infrastructure dealing with receiving messages from one side and sending them actively to other parties that are waiting for those updates, for those messages. Now, this is really still abstract. What's a message? How does the communication work and everything? But that's the basic idea of a messaging platform. Yes, C# guy, yes, while loops with true. Who hasn't done that? So everybody
Exactly.
has been guilty of polling. You know, by the way, in web development, there have been several improvements based on polling. So there has been the long polling, so-called the HTTP streaming solution. There are server-sent events. So they are all sort of solutions, partial solutions to this problem. But in a sense, they all feel like very ad hoc things. They lack, say, general, they were not general enough and not strong enough. So actually, when it comes to web development, the modern way is the WebSockets, or HTTP2 also offers some native things, but let's speak WebSockets. Indeed, today we are going to use WebSockets. But I want to stress that this fact, this problem and its solution is not specific to web development, because even if you have an enterprise application, backend application that has to speak to a database to get data, you might have the same problem. You might have the same need, and asking the database actively might not be the right way to go about it. Okay, so communication. What we want is that every message coming from a client is directly routed actively to other clients. And this is what we want. So messaging platforms or messaging systems. There are actually various reasons why messaging systems were invented, were developed. One is this push, not pull philosophy. So the server wants to be able to push data instead of waiting for the clients to pull them. Then something that Rags has mentioned, decoupling. So we want to be able to decouple the agents that produce data from the agents that wants to retrieve those data. So we want to do something more sophisticated than a direct communication. So we need a third party in the middle, a middleman or a message broker, we might call it, that receives messages from one side and then maybe with some complex logic also delivers them to the other side or sides. In general, this also comes with the advantage of non-blocking communication, because in the old days of, say, RPC exchange between applications over a network, it was a blocking call. So you would have your game frozen until the server and the other clients acknowledge having received the update. And that's really not a very smooth gameplay, right? So if we want non-blocking communication, we have to consider different phases. One is when the client sends the data, and in a completely asynchronous way, another phase where the client receives pieces of data. And this is exactly a non-blocking kind of operation. So the game proceeds while we are still waiting for the data to come to us. Okay, in other applications, say in analytics workloads or in, I don't know, if you have to analyze new information about user clicks on your site, messaging systems might also help in having a faster response to new data. So instead of having, say, every 5 minutes your cron job that wakes up and checks for new things and does the missing parts of the analysis, you might have, with a messaging system, you might have your analysis that starts as soon as new data comes there. So these reasons are also a good match with the modern microservice-based architecture. So as soon as you start breaking down your monoliths in very small pieces that are as loosely coupled as possible, having a message system that mediates communication between the parts is going to be very important and very helpful, right? Okay, so what does a messaging system do? We say that in a few ways, and I hope some of the answers to your question I've seen in the chat are starting to be clear. We want to decouple sending and receiving, which, by the way, also makes it possible to have parts of your application, parts of your architecture written in different languages. So as long as they follow specifications, you can break your application in parts that might speak different languages. A message system also plays the role of a buffer because as soon as you have a synchronous way of communicating, when the producer, when some agent sends a message to the system, it's not necessarily delivered immediately all the way to the final recipient. It might stay there in the message system, waiting for the moment when someone needs it. Maybe the final destination is offline for a second or whatever. So a message system also plays the role of a buffer, which opens a lot of discussion on how to effectively store the data and make it fast to retrieve and whatnot. A message system usually supports various ways to deliver messages, various patterns of usage. So we will see them quickly. The two main choices are between a shared queue and a pub/sub or fan-out approach. And then these messages, what are these messages? Well, they can be, well, at the lowest level, they are usually binary strings or strings of characters, whatever, but they might have a schema imposed on them, such as Avro schema, with intrinsic validation by the message system, or they can be, I don't know, JSON encoded. So this really differs depending on which messaging platform and which configuration you're looking at. But okay. Now there is something to be said on messaging systems, because we are in a sort of golden age for them. Because you remember when there was the time of database NoSQL revolution. So about 10 or 15 years ago, so big data was a novel concept, and the web scale of data was a new thing, and basically there was a revolution in an explosion, a Cambrian explosion of databases, in particular in the NoSQL sector. And we are sort of witnessing the same in the realm of messaging platforms. So you see the three most relevant maybe platforms are RabbitMQ, Apache Kafka, and Apache Pulsar, and they all came out in a handful of years. Apache Pulsar in particular is pretty recent. but let me say that Kafka is probably the one you have been heard about the most. I don't know, Rags, what do you think? Everybody knows Kafka. At least everybody who deals with messaging knows Kafka, in my opinion.
Yeah, I think Kafka has been around for a little longer, right? But we'd like to think that Pulsar has some advantages as well.
Yes.
So we can kind of go through that. But you're right. I mean the pattern is the same, right?
Yes, absolutely.
But the philosophy is the same. The paradigm is the same.
Yeah.
But there are definitely there are certain things like, for example, you can do JMS. I know there are people talking about Java here, so I just wanted to drop it in. Easily with Pulsar, whereas it's not easy to do that with Kafka.
Yeah, that's a good point.
Yeah.
Yeah. So we will look at Pulsar in more detail, but let me say that there are new novel, so there are modern messaging systems, and they sort of build on the shortcomings of the previous ones. So we are learning a lot, but the point is that with every year there are more and more usages out there that call for messaging systems. So in a sense, even 10 years ago, there was so the need for messaging systems was not so ubiquitous, let me say. So a messaging system that is very modern, such as Pulsar, has already been built, keeping in mind today's challenges. So we will see some of them very briefly, because we are not focused on the internals of Pulsar today. But so what are the use cases for messaging? In general, you might have a data set that is never complete in any meaningful sense. So think about having a batch processing cron job that every night crunches the last day's data and finds some insights. Okay, so every night you have your analytics running, but this is really an arbitrary choice of slicing in one day parts. You might as well think of having an hourly cron job that works very much more frequently and crunches up a smaller amount of data. Because say you have your website and you will get data forever, basically. So any kind of slicing of your data set will be arbitrary. So in this sense, the data set will be never complete. By the way, if you think about making the slice thinner and thinner and thinner, you're basically moving from batch processing to real-time messaging-based analytics, which is what messaging is there for. So if you have a data set that keeps pouring in new data points in a continuous way, you probably need a messaging platform at some point. Or you might have the need for sharing a queue of to-do items. So let's say you have, I don't know, the typical example is the meme generation website. There might be a queue of images to process. It would be great to have a messaging system just to store a queue of items that have to be processed, and maybe one or more agents pulling to-do items, processing them, and marking them as done. That is, deleting them from the queue. Okay, so this is very general, but if you look around in practice, there are IoT with a lot of sensor data coming in all the time. There are social media updates, notification, I post, you mentioned me and whatnot. There are, I don't know, self-driving cars and similar automation issues, financial data, online gaming. So there is actually a lot of situations where messaging, so real-time event streaming is more suited than a database, sort of, because there is a continuous trickle of new data points, basically. Okay, so this picture wants to sketch something that by now you should already have somehow glimpsed. So a messaging system is at the center of exchange of messages, whatever they are, so binary strings, whatever. So there are producers, and this is a bit of terminology. There are producers that create these messages and send them to the system, and there are, on the other side, consumers. And the consumers, what they do, they just take the messages from the system. So this is the basic idea. Now, we already mentioned that this is a asynchronous operation, because yeah, we might have a consumer that is offline and then it comes up later back to life and wants to get the messages that have been piling up in the meantime or similar situations. So we want full asynchronicity. And this involves the question of probably in a messaging system, you might want to have a look at what is the retention policy for messages. So are they deleted as they are after a given time, or will they be deleted when a consumer has used them and marked them as done or whatever? Which brings me to another point. So in a messaging system, you might support different guarantees of delivery. So we probably want a messaging system to ensure that all messages are delivered to some consumer. Now, this is something that we usually require. Something that we might require is exactly once delivery. That is, we want to guarantee that no message is delivered more than once. Well, this is a bit harder because of, network and intricacies of possible types of failure that can occur over a network. And you know what? In most cases, that's not even so important. So having an exactly once delivery guarantee is really, in most cases, is too much and is expensive. So in most applications, you might just be happy with at least once delivery, and then your application code might have to do some tricks to handle possible duplicates. Okay. So we mentioned that there are different ways of consuming messages, and the shared queue is one of them. Look at the picture. So we have producers that creates message, and the messages are stored in a topic. By the way, you will hear the word topic a lot because topic is, in a sense, the smallest unit of. So let's think of a topic as a pipe that routes messages. Sorry for the very harsh approximate analogy, but a topic is a logical grouping of messages that usually are to be thought in an ordered manner, and they are filled on one end and they are consumed on the other end, so to speak. So messages in a topic in the shared queue pattern are shared by the various consumers that are taking them. So we might have several consumers and they are all drawing messages from a given topic. And we have an exactly once delivery system. So every message will be used by a single consumer. We mentioned the idea of a to-do item list, and this is how I would describe it. So let's say there are some expensive processings to do on each message. Probably what we want is every single message has to be processed only once. We might have more than one consumer, so they will share the queue and every message will go to exactly one consumer. A topic is more or less a first in, first out queue, yes, conceptually, but not exactly because, and I was about to mention that with this consumption pattern, you might have out of order messages arriving. That's because one of the consumers might get a message, then something might fail, it will not acknowledge having processed it, and this message has to go maybe to some other consumer, which in the meantime has processed many other messages. So if you need ordered delivery, that's not for you. An example is, Rugs and I will maybe go through the homework submissions later. So I will grade some of your homework and Rugs will grade some other of your homework. So the submissions will be in a longer list of to-do items. Think of that as the queue in the picture. And we would like to have a messaging system to tell us which homework I should grade and which homeworks Rugs should grade, to avoid doing the same work twice. And that's exactly a shared queue situation. Okay. A good thing of this pattern,
and sometimes it may actually be a workflow where, you may want to look at it, like let's say I say, okay, but you have the final authority to say, well, it's good or bad or whatever, right? So So there are a number of different workflows we can set up, and I think
Yeah.
messaging gives us that kind of flexibility to be able to do that.
Yes, exactly. Because the other big idea, the other alternative idea is PubSub, or better, fan out. So we might have producers putting messages in a topic, and then many consumers will just tune in to this topic, and every one of them will get all messages. So that's a very different thing, because it's more like, I don't know, we all have our analog radio and we tune to the same frequency. We are hearing the same music, all of us. Or maybe Rax and I will follow the same Twitter handles and we will get the same list of posts. Similar things. So a PubSub, or better, a fan out pattern, is the one where every message goes to the topic and then it is delivered to everyone that is subscribed to this topic. So that's cool because it allows for, it is a low resource way to broadcast messages. And it's also cool because any new consumer can tune in at some point and they will just start getting new messages. Or they can tune out, so they can cancel their subscription and will stop getting the new tweets by the handle that they don't follow anymore. But now think about that. This is exactly what we need for our game architecture, because any move by any single player will have to be routed to all clients connected to my game. Because I want, so if my player does something, I want every other player to see me on their screen doing that thing. So this is exactly the kind of pattern we need. Indeed, each player has to receive all updates to the game world coming from all players, all other players. So this is the pattern we are going to use in our game, at least conceptually. Now, before going on, I would like to stress one point. Messaging are not databases. There are huge differences. The most important difference is that in a database, data is there at rest. So there are tables or collection, whatever you name them, and data, so records, are sitting there quiet, waiting for me to query. In a messaging system, data is in transit by assumption. So they are built around the idea of making transit of data efficient, fast. And instead of tables, you speak about topics usually. So, for example, all the complex indexing and joins that are usually possible in databases are probably not at the center of attention in a messaging platform. So data at rest, database. Data in transit, messaging. That being said, in reality, there are many similarities, and actually the boundaries are a bit blurred between the two, because messaging system, modern messaging systems at least, so the log-based ones, offer some kind of persistence of their data. And conversely, databases, some of them at least, are equipped with change data capture, which is basically a service offered by a database that makes it possible to tune in to all changes that occur in the database and just hear update after update, every change that is occurring to the database. So actually, by the way, Apache Cassandra has been given the gift of CDC these days. So it has been released really a few days ago. And I encourage you to play with it because it's pretty cool. It makes it possible to do wonderful things. But the point is that if I were able to listen to the CDC stream from my database from the beginning of time, I would be able to reconstruct the full state of the database now, no problem. So that's the point. And another way of mixing these two ideas is that there are, let's say, a modern data stack today, a modern data infrastructure will probably use both messaging systems and databases coupled in various ways. So gate basher today is 2 hours. So we are not even midway. Okay, so I think I'm running a bit late, so I will skip some more internal details. Let me just tell you one thing. I just mentioned that modern application architectures probably usually have both messaging and database storage. Today, we will not have a database at all. So this is a first, I guess, for us. We will just not create any database, not use any database, and we will just focus on messages. So I will show you that it is indeed possible to have a simple game that has no persistent storage. Obviously, if we want to make our game a bit richer, there will be at some point the need for persistent storage. Okay, Gate Basher, I'm sorry to hear that. Duly noted. We will make sure this will be corrected for the next workshops. Thank you. Okay, so just one thing. Messaging systems are complex. They are huge pieces of software, and they require pretty some expertise to be created the right way. So they have to be high performant. They have to guarantee the correct delivery of messages. Probably we want them to be fault tolerant. They have to support some failover policy. Maybe data have to be replicated in the right way to avoid, crash, to have the crash tolerance. They need to support some sort of scaling and so on. So it's really a difficult thing. Not only that, but even just operations might sometimes be not trivial. I think everyone who tried to repartition a Kafka topic knows what I'm speaking about. And guess what? That's why today we will have a managed solution to take all of these problems away and concentrate on the important bits. Today, we are going to use Astra Streaming. Astra Streaming embeds Apache Pulsar, or is built on Apache Pulsar. So first, let me tell you quickly what Apache Pulsar is. It is a messaging system that was one of the most recent ones, born at Yahoo and then moved to be a top project in the Apache Foundation. It is a messaging system supporting the two main delivery patterns, so PubSub and shared queue pattern. One of the key ideas behind Pulsar is that to split compute and storage. So you have an Apache Pulsar cluster. There is a subcluster handling storage of data. So just the messages are stored there in a particularly replicated and distributed way. And another independent set of nodes in the cluster will just handle connection to producer and consumers. And this second part is stateless, so it's intrinsically able to withstand crashes and restarts, no problem. Other very cool features of Pulsar are multi-tenancy. I will show that in a second. It's rather easy to scale it horizontally, which is a must in today's world because, cloud native architectures and so on. Indeed, Pulsar has a rich support for Kubernetes deployments. Pulsar has high performance, high throughput, and low latency. It's designed around a few technical ideas that allow for a very astonishing performance. And it supports geo-replication. So you can configure a Pulsar cluster to be a Pulsar instance to be replicated across geographically far away clusters. Then there is something else, but let me gloss over it. Astra Streaming takes Pulsar and makes it into a managed service in the cloud. So basically, with a few clicks, you will have your own Pulsar cluster up and running. You will create your streaming topics, and then you will be using that to run the game on. Okay. Multi-tenancy and logical structure of Pulsar topic. So if you think of a single Pulsar instance, let's say a Pulsar cluster, whatever, if you think of a Pulsar cluster as a big house, there are apartments. And that's cool because apartments are occupied by several tenants and they do not know of each other. Anything a tenant does will not affect any other. And this is the principle of multi-tenancy. So a single Pulsar instance will support logically and strongly separated and independent tenants. So you see in this house, there are a few other people, and then there is you with your tenant called game server or whatever you will call it. And then how are the topics logically grouped? Within your tenant, the topics will be grouped in namespaces. And by the way, we will be using the namespace called default. And within a namespace, there will be topics. So you see there is a tenant called game server, which contains a namespace called default. And then there is a topic called word updates. So you see in the balloon here, the fully qualified name for your topic will be tenant / namespace / topic name. And this is something you have to remember because you always have to start with a tenant. Okay, let me skip the architecture bits. And then finally, we can move on to the first practice part. So I will give you again the link to the GitHub repo just for you to better follow, but don't worry, because I will jump myself on the repo here. Okay, so you see the repository here, and this is, by the way, this is designed to be self-service. So anytime you can just go here and follow the instructions in this README. I will do them, basically, I will do the same. And the first point we have to start with, so, okay, by the way, if you scroll down, you see there is a section telling you how to do the homework and how to submit it. I will show that later. But let's start with step 1, creating your Astra Streaming instance. So we said what Astra Streaming is. So please just locate this orange button, Create Astra, here. And click on it. Maybe right click to open in a new tab. Okay, so let's see if Nightbot gives me the link. I will drop it in the chat anyway. So if you click on this link, you will be able, here, there we go. Thank you, Nightbot. So if you click on this link, you will come to a page similar to this one that makes it possible for you to register to Astra. Name, work email, password, whatever. Then you create your account, and you will. You can also sign in with your GitHub or Google account. So this is completely free. Let me stress that. Creating an Astra account is free, and obviously I already do have my own. So let me log in while you are signing up. This will be required for you to create your own free streaming topic in a second. There we go. So, sorry, I have to. Okay, sorry. This should work. Okay. So if you register, you should be able to enter Astra, and this is the interface you should be seeing. Okay, so let me stress this is free because Astra is actually a single product containing a database offered as a service, which is famously AstraDB, built on Apache Cassandra, and currently in open beta. There is also the streaming, which is what we are going to use. Okay, so I will give you 1 minute or so to just make sure everyone is able to register here and they came to this point. And in the meantime, we go ahead. Okay, so maybe I can just go on at this point. So, okay, let's assume you all have your own Astra account. Today we are not creating a database, and we will just directly jump to the Create Streaming button here. You see next to streaming, there is a nice Create Streaming button. If you click on this, you will be able to create your own streaming tenant with a namespace and a topic in it. And the topic will be used to run the game. So let's start by creating the streaming. Now there's a trick. Streaming names have to be unique across accounts. So if I will call my streaming topic game server dash 221, you will be not able to use the same name. So please, what I suggest is you call it game server dash something, whatever, ABC, XY, whatever. But then maybe you want to keep this name. I will store it in my text editor buffer here, and I will go ahead and create a tenant with this name. So please choose a different name, just a random different name, and remember it. So we are creating.
Just use your name or something.
Yeah, exactly.
So it's easier.
So create your tenant. You remember the tenant is the name on your apartment, right? Okay, so you have to select a provider and a region. I'll go for AWS. Why not? But that's any choice is okay. No, okay. I'll go for Google Cloud that I think offers Europe, if I remember well. Yes, I'll go to Europe. And that's it. So tenant name, anything, game server, something. So maybe I will write in the chat. Any name that is not taken is good for you. Then you choose a provider and a region, and then you hit this button. You see, create tenant. Oh, maybe you can't see it very well now. Sorry. Oh, okay, so there you go. If you click, somebody beat me to this game, so I have to change the name. Game server 2211, create tenant. Okay, there we go. So you see, someone stole the name, and I had to change it. So let me update. He's here. You beat me to it. Okay, so you see it's very fast, and the tenant is there, ready for me to create topics on that. So I would like to ask you to give me a thumbs up if you get to this point and you have your tenant up and running. Please give me a thumbs up if you managed to get to this point and you have your tenant ready. Yes, blackmagic.exe. Yes, this technology can be self-hosted. I mean, Pulsar is a Apache project, so it's open source, and it can be deployed in any conceivable way, let me say. So you can run it on your own laptop, or probably in your own data center, or in the cloud with or without Kubernetes. You can just let Pulsar run in any way. If you want a managed solution, that's obviously within Astra Streaming, because that's managed, but the underlying Pulsar is a completely open source project that you can run any way you want. I'm very happy to see a lot of thumbs up. So let's continue, because we created the tenant and we will be using the namespace called default. You remember this block containing topics, but let's create a topic. And to do that, you see, I'm now exploring my dashboard for my own tenant. If you see, there is a tab here called topics. If I click on topics, I will be having a list of the existing topics. Well, there are none yet. That's why I want to click on add topic. I click on add topic, and guess what? I can create a new topic. So as opposed to tenants, they do not have to be unique across the whole universe. So you can, and I suggest you to use the very same topic name as everybody else. Topic name, use word updates. Let me check, because it should be word updates. It's all written here. Word updates, very good. Okay, so make sure persistent is yes and partition is no, and you can hit save. So topic name, word updates, save. By the way, yes, so in 1 or 2 seconds, you will see the word updates topic appearing, and that's there, ready for me to use. So we have our topic in the default namespace in our tenant. So all of the infrastructure, as far as Pulsar is concerned, is there ready for me to use. And before moving to the next part, I just want to show you that if you go to the quick start, or sorry, if you go to connect here, now I made my interface a bit bigger to, I increased the font size to make it easier for you to read. But anyway, if you go to the connect tab here, you're able to see all details of your topic. In particular, I want to point you to this broker service URL, which is something that I want to copy and store in my own text editor buffer here for later usage. And so broker service, so okay, once you create your topic, you go to connect and you can have an overview of the connection details, the secrets, so to speak, and the connection strings. Important bits for us are broker service URL here and token. Now, token, you do not even need to show it because it's a very long string of gibberish, blah, 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 blah. But if you click on this button, you are able to copy it. And maybe out of convenience, I will store it here. You see, it's a rather long, random looking thing. Okay, so Simon asks, what does persistent mean? Yes, you remember when we said databases are not streaming in streaming platforms, but there are some similarities. So a layer of persistence is there also in a messaging platform. Think about crash tolerance. So I have to store on disks. So if there is a reboot, a crash, I will not lose my data, right? So that is the level of persistence this persistent refers to. Pulsar also supports non-persistent topics, which might have some cases, and they actually offer a higher throughput. You can imagine because it's all in memory. But yeah, you lose the ability to recover after a crash or reboot. So depends on your use case. If you have really volatile data, maybe there might be even better. Okay, so we have created a topic, and we have here gotten the token and the service URL ready for later. So with that, I would like to stop the practice for a second and come back to a bit of slides.
So Stefano, unlike our DB Astra token, which goes away when you navigate away, I don't think there is a problem here.
No
right?
problem,
So,
exactly. So
yeah. So don't worry if you.
Yes, don't worry. You can navigate away. You can navigate away from this tab. You can come back to connect, and your details will still be here. Yeah, exactly. Thank you for pointing out. Okay, so make sure you're able to reach this information because that's needed later. And with that, I want to jump back to the slides for a second and very quickly tell you something more on how is the game structured. So we have a client sending messages to the server, and the server is basically an API. It will be a process running on the server, actually on the same machine the client runs, but on the same machine the client is served from, but that's a coincidence, so to speak. So client sends messages to the API. The API will be in charge of speaking to the topic, to the Astra Streaming topic. So you see the messages go from the client to the API on the server. Then from there, they go to the streaming topic. And from the streaming topic, they will be received by the API, which also serves as a consumer from the topic. And the API will be delivering messages, that is game word updates, to all clients out there. Now, to make everything easier to think about and to reason about, we will not have any case where a message comes from a client and goes straight to other clients. Every message that reaches the API will be routed to the topic, the Astra Streaming topic first, and then it will go back to the API. And from there, it will be broadcast to all clients. That's a choice. It makes for a simpler architecture to reason about. And it also opens the way to having, several API instances running and serving different blocks of clients, and everything would work because every communication would happen through the Astra Streaming, basically. That's one point. Another point is we will need some kind of validation of client input, and that will happen as soon as messages come from the client. It will happen on the server side, on the API, but from that point on, we will trust a message to be valid. So when a message comes from the topic, is consumed from the topic by the API, it will then be routed, no questions asked, to all clients. That's another choice. I would say reasonable one, but okay, let's go ahead. What technologies are involved today? Well, some of them we already mentioned, so I will start from the far right. Astra Streaming as a messaging platform. We will have Python to run the API. In particular, we will use a framework of a modern Python called FastAPI. I hope there will be time to go much in detail on that. So FastAPI will run the Python code that makes for the API, the server side, and it will communicate to Astra, so to Pulsar, through the ordinary Pulsar Python drivers. The communication between client and server will be, yes, FastAPI is cool, Alessio. I agree. The communication between client and API will be done through WebSockets. So WebSockets are a very useful and well-performing way to have a full duplex communication between web servers and web clients. And they allow for servers also to initiate data push over a connection that is kept open for a long time. So this is all cool, and this is exactly what we need. So we will have WebSockets between client and API, and Python drivers between API and the streaming topic. And just a remark, there are so many of our other workshops are actually serverless. So they have no server proper to speak of. But in this case, especially thinking of a future extension of the game where there is some state to be kept, and probably it makes sense to have a server keeping tabs on what's happening in the game world. That's not necessary, but still is how many of the online games are structured. So what technology are we using in the client? Well, that's going to be React, which is a Node.js, very well-known framework for building reactive applications. We will not go, this is not a tutorial about React, but if you're interested in the GitHub repository, you will find a link to a React starter tutorial that is very useful for you to start getting an idea of how React works. Okay.
So Stefano, I know, I'm cheating a little bit here. I know I've seen the Menti questions.
Okay.
So the previous slide you might want to pay some attention, because I know there are some questions around that, right?
Okay, yes, that's why I repeated everything. So client is in React.
Perfect.
WebSockets between client and API. API runs Python code. So it's server side and it runs Python code. And that is where validation of messages takes place. API, FastAPI is the framework, Python framework used for that. API is the only actor writing directly to the Astra Streaming and reading from it. So it is both a producer and a consumer of messages on Astra Streaming. And there the communication is is done through the Python drivers. Yes, thank you for pointing that out. Might be useful. Okay, so very quickly, what is the kind of communication? So what are the messages flowing around in this game? Well, basically, the most important thing that the clients have to publish, to send to the API is, I am player with this particular name, and I am at position X, Y in my game area. Because this game will be just players moving in a rectangular game field. So the most important update the client will be sending to the server is, I am now at position X, Y. And this is the shape, the message. This is the shape of the message. So that this is the message of type player, and it will just have a payload saying player name is Mark, X, Y are this and this. So this message is sent to the API by a particular client, because that's me. That's my own, I'm Mark, let's say. The API will then perform some validation and will enrich the data with a player ID, and the server knows that player ID. And from that point on, this message will be just doing the full round trip all the way to all other clients. That's the basic of the messaging. There are actually other kind of messages used in this communication protocol for this game. There is a trick. So if a client is leaving the game, it will just send a message with null coordinates just to notify everyone else that they left the game. So every other client will be able to, stop drawing a given player in the field. Then there is an in-game chat. And so you see the message will be of type chat, and it will contain basically the text to show in the in-game chat by every client. And then there is a special message that will be sent only once, but directly by the API, no streaming involved, a message of type geometry, because when a client first connects to the game, the API will tell it, wait, you are playing on a field with this size. So the world you are playing in will have these and these features. This is something that the API directly sends to the client, no streaming involved. And it is a message of type geometry. But anyway, you will maybe see them in the game. So very quickly, I want to stress that for simplicity reasons, we will have all messages going through the same one topic. So they are different kind of messages, chat, geometry, player positions. They will just be serialized as JSONs and flow through a single topic. That's probably not something you would do in production, where you would carefully design all of your topic and maybe impose a schema on top of them. But now we don't want to get mad at creating a lot of topics, so we will be working in a simplified setup. For the same reason, to keep things easy and simple and easy to inspect, we will have two separate WebSockets, even though that's bidirectional actually, but there will be a player WebSocket used only for client to server communication, and a Word WebSocket used by the API to send Word updates to all clients. That's just to make everything easier to see when it happens. And now let's start having some code running. So if you go back to the repository, and I will drop the link again, or better, I will ask Nightbot to give me the link. I will switch to the repo again. We are at step 2A. So we want to take this repository, in particular the code, and I want you to start your own IDE browser tab where you will be running the code and looking at the code. So if you click on this open in Gitpod, maybe I suggest you to right click and open in new tab. What happens? Something very cool happens, because Gitpod, open link in new tab. Open link in new tab. There we go. So something cool happens because I will go to Gitpod. I will log in with my GitHub credentials, and probably I'm asked to authorized, blah, blah, blah. So I'm actually just doing a single sign-on thing. So I'm back to the Gitpod interface, and what's happening now? Gitpod is creating an instance of an IDE in the cloud for me, and there we go. So you see, we have, let me make this a bit easier to navigate. If you open in Gitpod, you will be having a local clone of the repository with all code ready for you to inspect. And it is something that looks like Visual Studio Code, basically, and it is in the cloud. So everything in the browser. So maybe I can ask you to give me a thumbs up if you manage to locate this open in Gitpod button, and if you manage to open the repository here in your IDE in the cloud. So please give me a thumbs up if you get to this point. And as you see, okay, thank you. It's working for a lot of you. That's very great to see. What's happening behind the scenes here? Well, we equipped this Gitpod initialization with a few cool dark theme. It should be
It keeps
this
coming up
hamburger menu. Don't remember, maybe file something.
I think it's /settings and then, something along those lines.
I don't, preferences here. Maybe it's here, settings. It's really...
yeah, settings here.
Theme.
I will send a link.
Okay, so yeah, I will go back to... So, okay, we set up this Gitpod initialization in a way that does already some secret dependency installation for us. So we can just go, oh, right, the cog and the color palette. Okay, so here, manage, settings, no, common palette, color theme here. I think it's this one, yes. So, okay, for the dark mode, you click on this cog icon and then there is a color theme menu that pops up. Thank you, the Frois. Thank you. Okay, so Gitpod. You now have an IDE where you can inspect, modify, and run the code as if you were developing locally on your machine. So you have a file browser on the left, a file explorer here on the left, a text editor here on the top, which incidentally is also opening the README, but that's just that's basically where you edit code. Let me show you. This is where you edit code, you see. And then on the bottom panel, you have consoles. You see, those are just simple consoles. If you see client ready, you're probably good to go. No, you do not need to fork the Gitpod repo. So today we do not fork, we do not copy. You just, basically what you did is you went to a development environment, and you git cloned our repository. That's it. So no problem. Okay. The pip install is done already for you. So we already secretly configured this Gitpod setup to do something for you already. So we should be ready, good to go. Let me tell you one thing. We will have client and API running here on the same Gitpod instance in development mode. For these reasons, I want to point out that here on the bottom right, you have navigation. You can navigate between two different consoles. There is one called Setup API, which is where you see API ready to start. And this is where we will run the API. And another one is the Setup Client, which says client ready to start. So if you were developing in your own local machine, I would maybe open just two consoles, but that's the same. So you have two consoles, and that's important because we have to start to have two things running at the same time, right? Client and server. Okay.
And I think the documentation also mentions it as API console. So if you're wondering what it is, I think Stefano did a great job of explaining.
It should be self-explanatory. Also for those of you who like to do that later by your own, that should be not a problem. Otherwise, reach us on Discord, whatever, and ping us. Okay, so first thing, let's set up the API. So pay attention. I'm going to the API console here, the one that says API ready to start. And to answer Veronica, you see actually, yes, there was a pip install, but we did it before. We did it for you, so it's ready to go, except one thing. So this is the console we will be running the API in, but we need to tell, so each one of you need to tell your API running application to create the env file, right?
So there is a hint by Gonzalo, Control plus K plus T. Maybe it's to navigate between the consoles. I don't know. So maybe I can try that and see what that means.
Okay, it opened me a new tab because it's Control T. But okay, it's up to you to find out. I'm now. I have to go.
Yeah, exactly.
Okay, so we need to give some credentials to the API in order for it to be able to connect to your Astra Streaming. It's for changing the theme. Very good. Okay, so there is one important thing to do, and it is you see there is a dot. So if you open the API directory here, there is a .env sample that is a example env file, environment file. And you see there are three rows here that define the streaming tenant, the service URL, and the Astra token. And guess what? They are exactly the three connection strings and secrets I asked you to pay attention to and to copy. So you should first make a copy of this file, which I do by command line. So cp.env.sample, and I copy it as .env. So maybe I can write this also here. So I am in the API console. I do this to create a new file called .env, which will be the real thing. And I can edit it. So I open this .env. And you should have to replace the tenant, the URL, and the token with the values you used before. So I create, you remember I had the tenant called game server 2211, and I will put it here, and please leave the quotes. I will take the full service URL string, and I will put it here as service URL. And then the very long string that is the connection token, which basically provides for secure authorization, I will paste it in place of this placeholder where it says Astra token. So if you now save your .env and make sure it contains these three lines, can you read what you see on my screen? Because it's a bit small, maybe. I can try making it a bit bigger. Maybe like this might be better. So I copied .env sample into .env here. And I just edited these three settings at the top of the file to reflect my own settings. Okay. So once I'll give you how do I save the .env? Well, it depends. What I did is I just copied it with the cp command. I think you can do that also with the save as. Somewhere there should be a file. Yeah, you can just open the sample file. I'm answering to SQL Master 123. You can open the sample file, and then there is this hamburger menu, file, save as. You see, file save as, and you save it as .env. For example, this is one of the ways. Okay, so let me close it because I'm focused on the .env. That's the important one because these variables will be picked up as soon as I start the API. The cd API command is not in the README because if you work in Gitpod, as far as I remember, you start already in the API directory. That's why there is no cd API to use, Veronica. But if you work locally, you will have to make sure you can delete msample if you want, but that's not a problem. It's part of the repo anyway. So if you delete it, you will just have to commit. But anyway, okay. So we have our env, and it's time to start the API. So what you start the API with? I see. That's strange, Veronica, but I think you look like you know what you're doing, so please cd API in that case and pip install. That's very strange. I think your Gitpod might have run into some weird problem. So you might encounter some more strange things along the way, but hang on and try. Otherwise, in the worst case, you can maybe do it later. Okay. Well, so everything worked. Very good. Okay. So Veronica, no problem. Okay. So how do you start the API? Uvicorn API : up. That's how you start. Because you see, Uvicorn is a AES-GI gateway able to run fast API Python code, but we don't have time to go much into that. So if you type Uvicorn API : up, I put it here. Ah, come on. Okay, an apple can appear. So if you type UVcorn API up, you should see something like this. That is telling us, okay, the API is up and running and is waiting for connections. Very good. Okay, so that's it for the API. Now, let me go to a very important point. We are almost, no, okay, sorry, we do another thing. Sorry, let me go back to Gitpod. There is so the API is basically ready to go there. We do not have to change anything more. So let me turn to the client. The client, even though we did everything already for you, yes, environment variables not detected. Probably there is a .env file missing, or it doesn't define. Yeah, so apparently UVcorn command not found. Probably there is a pip install that did not happen on your Gitpod, which is very weird. So, but that's very strange. Is someone able to run the API? So is someone, please, if you manage to have the API running, please give me a thumbs up. Okay, yes. Okay, so those of you who are meeting problem, I suggest you to go through the README again and then maybe reach to us if there is something strange going on. Maybe you might be just in the wrong directory, in the wrong console of the two. Okay, so I see a lot of API up and running. So let me go to the client API, the client console now, and just...
One suggestion is, you can go ahead, delete the workspace and start a new workspace in Gitpod.
Yes, that's
sometimes we've seen some fleeting issues.
Have some hiccups, yes.
Yeah.
Okay, so just as a perfunctory thing, I will run an npm install in the client console. Actually, we did that already for you, so it's just to go through the motions. Otherwise, it would take a bit more, but npm install basically installs all required dependencies for the client application. And we stop 1 second here, and I go to the client, the slides. So very quickly, what happens when the client starts? Well, as soon as the WebSocket connection is initiated by the client to the API, as I already said, the server will send a geometry message telling the client, my world is so large and so tall, at which point the client will invent an initial position for the player. It will send the message player position to the server. There will be a validation by the server, and then, as we already saw, this validated message will go to the topic, and from there it will be picked up by the API in various instances. So every WebSocket connection will be, so every running function in the API responsible for any WebSocket connection will pick up these updates, messages, and send them, broadcast them to the client, which will then update the word and redraw. So that's the basic, you see time flows to the right in this image. Time flows to the right also in this image, and it is the basic item of gameplay. So you see on the client side, what happens is that, say, you click a button and your player moves around, okay? That means that the position changes, and thanks to the magic of React, a position change triggers sending a message through WebSocket to the server. The server validates, as we saw before, validates the value of a coordinate, basically XY. The message goes to the topic. The topic pushes the data to other parts of the API, the ones responsible for the word WebSockets of all connected clients. And then this update goes to every client for them to update the word and redraw the screen. Something more that happens is that this validation is then used by the client itself in this way. If I am the client and I'm getting back an update on a position, and it is about my own player, I will use this value to change my own value of XY. There's a reason, so we will come to that later. But see, a validated message, when it bounces back to the client, is also used to update my own knowledge of my position in the game. Then there is how the in-game chat works, but we will skip that. And then it's time to play. So if you have your API running on the API console, that's good. And we will just leave it there. what we need to do on the client API is a simple npm start. So with this command, npm start, the client project will start in development mode, and it will be available here in this very tiny and hard to use browser window. So let me take this URL. You see this URL is,
please.
sorry?
And paste it. So I want to play.
Yeah, exactly. So, okay, well, later, 1 second. So you will take this URL here, and let me open a new browser tab, a real browser tab. I paste my URL here, and there you see. So maybe I make it a bit bigger. You see, this is the game running. Let me change my name because there are random names drawn for you, but let me change my name to Stefano. And everything should be ready to use. So if you click enter game, there, I am in the game. So you see, now I made it a bit too big, maybe. I am in the game, and if you see, as you click on the arrows, my player is moving
Stefano,
around.
I want you to put that URL in the chat so that I can join.
Later. Let's go to.
Later.
No, that would not now. So, no, okay, we have to see important things still. So you see, this game is working, and I can also, by the way, you should also be moving around in your own world. If you click on the game field, you can use also the arrow keys on your keyboard. So you see, I'm moving around, everything works, and every movement of my player here is a message that does all the round trip from client to server, from server to Pulsar streaming topic, from streaming topic to the API again, and then back to my server, to my client, which is running in my local browser. So everything is, yeah, Vic, your spider isn't in the game, but your spider isn't in my game because we have different servers. I guess your spider is in your game. At the moment, every game is separate. That's a good point, but before trying to do a multiplayer proper thing, I would like you to try and go to negative coordinates. So you see, I'm trying to hit the left key a lot. I'm trying to get to negative coordinates. That just doesn't work. But look, if I keep the arrow, pressed for a brief moment, I can see negative values in my position. You see? But then I leave. Oh, somebody managed to get here. Hello. Hello, Notio Scopus.
They found the URL.
Nice to see you. Okay, so it seems to work. You spoiled my game. Hello, somebody else is coming. Okay. Now, if you try to go to the left, you see for a split second, you see a negative value here. How come? So this negative value very quickly disappears, and we are back to 0 in the coordinates. So why does this happen, and how? Well, in 1 second I will tell you, but first let me show you here that if you later want to dissect the code, or anyway see this messaging protocol at work, you might want to have a look at this status bar below, where you can see the last sent and last received message. So you can see what happens. So if I move, you see when somebody moves, you will see the messages changing, and you will be able to check if the protocol is the one we described earlier. Okay, so how come why are you able to see for a very short time, you see negative values, but then you go back to 0 in this case? Well, the reason is in the slides, because you see, we have client-side validation, and we cannot have. So it doesn't make sense to let the client do validation of coordinates or whatever it might be in a more complex game, because clients are cheaters. You know, as soon as there is an online game, there are cheaters. So it is absolutely a responsibility of the server to be making validation of input of coordinates or whatever. And you see it here. So what happened is that if my coordinate is 0, and then a message with 0 goes to the client, to the server, the server puts a 0 in Astra Streaming, and then I get a 0 back. All nice, all good. Then I click my arrow key, and my coordinate becomes 1. Same thing. 1 goes to the server is okay, 1 is a good coordinate. Yes, Vignesh Kumar, exactly. So correct. Client, you see the third case. Client sends a -1 because this is its local internal value it has to hold. It is holding. It sends a message with a -1. The API changes back to 0, and the 0 is what I get back. What the client gets back is a 0. Indeed, as I told you, the client is taking game updates back from the server and using them if they refer to itself. Uses them to update its most recent knowledge of the player position. So it is asynchronous, and we give the players a very good feeling of responsiveness of the application, but still we rely on server as having the last word. But then there is a trick, because something weird can happen. If you don't pay attention when you write such a game, you might end up in an infinite loop of conflicting updates. So look at this sketch. Time flows to the right. Suppose we have two very closely spaced user inputs. So we go from 3 to 4 and from 4 to 5 very quickly. Both trigger sending a message. This message bounces all the way down to the Pulsar topic, to the streaming topic, and then they bounce back to my client. So I might end up receiving the 4 after I sent the 5, which means, oh, wait, I am at 4, not at 5. But then I'm actually changing my local knowledge from 5 to 4, which means I'm sending out another message with a 4. But maybe in the meantime, my 5 is coming back, and so on. So I am stuck in an infinite loop of fake, non-valid updates, just because asynchronous. So if you having asynchronous messaging and having server-side validation is all good and nice, and this is the way it should work, but still there are tricks to pay attention to, because I might have such unpleasant side effects. And this is a typical implementation problem when you think about asynchronous systems. And in this case, how do we solve this? And this is exactly, the solution is implemented in the code if you care to have a look and try to track it. Basically, we want to avoid the 4. We want to ignore this 4 because it's not the most recent update anyway, right? And we do that by introducing a generation counter. So every client has an ever-increasing integer number that counts just the numbers, the updates, the changes in coordinate. Every time we send a message to the server with a new position, we attach the number of the generation number that was sent at. I will give the URL in a second, don't worry. So every time a message is sent, there will be this generation number attached to it, and whether the value is validated or not, that value, the generation number will do all the round trip and come back to my client. And I will just ignore updates that are not from the latest generation. So any update that bears a generation number too low, so they are deemed as stale values, old values, and I will just ignore them. So I break the loop before it starts. I break this vicious loop of conflicting updates before it starts, because I have a way to track obsolete updates from the server. So it's not perfect, but in an asynchronous system, this is the best you can do if you want to save the face in front of the player and give them an impression of fluid gaming. Okay, so we are now ready to do multiplayer for real. And for that, I will finally try to give you the link to my own game. I see someone. Okay, so let's try this. Please try to connect to this game. Let's see if this works. So you see, Okay, my screen is too small, but yeah, a lot of people seems to work. This is a very first in the history of this game with so many players. So I have to take a screenshot. Oh. I think I did something different. I don't know what I did.
It's strangely satisfying, right?
You know what? I don't know what I did. Okay. Sorry.
I can take a screenshot.
I closed all the windows. Okay, there we go. Yes, because I always think I'm on Linux, but I'm not. So
I took a screenshot if you want.
Okay, great. Thank you.
Yeah, good.
Okay, so as you move your spiders around, by the way, the reason why this game features spiders is because I really like spiders. It's one of my hobbies, to spider biology, so that's the reason. And I see some of you also found a way to do the secret trick of the hearts. Cool. Okay. So Atlanta, to get to the game, you actually, if you want to, you can just open the link I pasted to get to my game. So apparently.
Actually, you may want somebody who's already finished this to give out a link.
Yes.
And we can join that too. Yeah, that'll be even nicer.
Yeah, right? By the way, this is important. Every one of you will have a link that will work, and you can share the link. So the link to your own game can be shared with your friends, and it will work as long as Gitpod is not, as long as you don't close Gitpod. Secret trick is press H. Originally wanted you to have a look at the code to find out, but yeah, okay. Anyway, it's nice to see that it works. Okay, so before we go on, I think this is now. I urge you to stop a bit. So yeah, you have a heart. You know that spider hearts. Okay, so before you all get crazy about spiders, there is still something I would like to show you. Now, obviously, here I've been logged out, and I will log in again. I will refer you to the README to find more information, because there is not much time more. So in the README, you will find a lot of additional information on special parts of the game, how some things are implemented. I will briefly mention them for the curious out there. Let me just show you one thing that is important if you ever find yourself in need of debugging or experimenting with your streaming application. So I'm back to the Astra console here. Let me go to streaming, to my own tenant here, to my own topic. I will show you that you can actually eavesdrop on what's working, on what's happening in your topic. So you see this Try Me tab. This is something you might want to do on your own Astra if you have your application running on that one. You can tune in to your topic from the browser, from the Astra UI, and just have a peek at what's happening in your game. So you can basically use this interface to have a look at the messages that are flowing around. And if I click connect, okay, I see some WebSocket timeout. That's unfortunate. That's really unfortunate. Maybe we have too many messages flowing around. Yes, I think that might be. Yeah, that's too bad. Yeah, okay, so this is probably something that needs a bit of checking. So in principle, you should be able from here to, and I would ask you to do that when you do the homework, to also go through this interface to check how easy it would be in a development or debugging situation to interact with your topic directly from the UI. So you can also inject messages. Yeah, so doesn't seem to work today, and that's too bad. But then that means we have to move out, to move on, and stop here on that. By the way, it's almost time to stop. So
if anybody has a link, they can try it out and give us a thumbs up that it's working for them. It may
yeah,
be working for them, right? Because they may not have so many messages going through.
yeah, Vignesh Kumar. Yes, you could also move your own spider only according to what happens in the Pulsar topic. That would solve the concurrency, but that means you're back to blocking calls basically, because I click the arrow key, then nothing happens on my screen until the message goes around, and that might be just maybe milliseconds, but still that would give not a fluent, not a real-time appearance to the game. So that's why we anticipate, the client anticipates moving the player thanks to local knowledge of what the spider is going to move. But then if the server has something to say, such as this is not a good position, then that will happen. Okay, so yeah, okay, the streaming WebSocket might have some problem now, so we will just skip, no problem. Let me just show you that once you get this part working, if you want to do the full experience after playing the game, maybe with your friends, your family, nice spider gathering, you might try to cheat in different ways. So if you manage to get this interface working, you might also try to inject messages. You craft fake messages and inject them here, and you would see the consequences on your spider game directly. You will see fake messages in the chat. Yeah, okay, I see in the in-game chat. I wish this workshop had some coding involved. Well, there is no time in a workshop to write code interactively, but both in the README and in the slides, there would be more detail on some of the most interesting tricks that are employed in the code. And yes, as Veronica points out, the homework requires you to know what's going on in the code, both on client and server side, because you have to do some very tiny coding to have something more working in your application, in your game. So there are instructions in the README that makes it so force you to try to inject fake messages and see the consequences on the interface. Then there are homework instructions, which we will see very shortly in a second. And then you see, for those of you who ask about coding, there are some selected topics here described more in detail in the README about how do you do WebSockets with React, how is FastAPI structured, and also some neat trick with SVG, because the graphics of this game is based on SVG. So let me go back to the slides now, and we did the hands-on multiplayer. So yeah, so you see, if we had more time, I would point out how the client app, the React app is, so the main structure of it. So you will have a look at the code, because there is some explanation there. So this is the trick of React and WebSockets, but yeah, something about FastAPI. By the way, the slides are all there in the repo for you to read. So please have a look and come back to us with questions, whatever. We would be happy to, go in more detail. Something about Python, Pulsar, and WebSockets. How do you do React graphics? At least what is the trick we employed with React graphics? So there might be some possible directions for improving this game. The most ambitious one is to introduce player-player interactions and player-word interactions, which are not there, and that's because there is no DB, no persistent storage other than the topics, other than the streaming platform. Okay, so I think we are now, Rags, in the position to do the quiz. So
right.
We've been playing with spiders, and it was very good to see a lot of spiders jumping on my game and moving around because, as you all know, I like spiders. So, but now it's time for you to take a quiz and maybe win some swag. So, Rugs, if you're okay, I will switch to your screen for the quiz. And
Absolutely,
I will try to put on some music. So, quiz time.
This is the fun part that everybody is waiting for, right?
Yeah.
And again, I know you'll get these instructions, but don't look at the screen, but look at where you have Menti, because there is definitely a time lag, and you may not be able to be on top of the leaderboard.
Yes, so please, yes, I will send the code again, but you can see it on screen as well. So maybe you are still connected from the beginning of the workshop. Otherwise, please jump to menti.com and enter this code or scan the QR code, and you will be able to give us your answer. Now, for what is coming, you have to answer with the correct answer, but also you have to be fast to get more points and to jump on top of the leaderboard, because the first 3 will win a prize. Okay, so maybe I can move you a bit on the left to have a look. So yeah, many of you joined already. We can wait another minute or so for all of you to jump on board.
Perfect.
So look at your phone, please, because otherwise you will be suffering from a undeserved lag if you look at YouTube.
Yeah.
Okay, so 80. Can you hear the music?
Right.
Is it too loud, maybe?
I don't hear music. Oh, maybe not. Sorry, I have the volume low. So
No, okay. It's there, but it's maybe I can increase the volume a bit. Yeah, let's see. Okay.
Music is good.
Derek, I suggest you to take it easy and to go through the README instructions on your own with your timing, because any maybe small issue that occurred now might involve some troubleshooting, and I suggest you to go through the README and do the practice by yourself, because the README is pretty self-explanatory. But in any case, please reach us on the Discord channel, and there we will be happy to help you if you can tell me where you get stuck, but not now. So it's now quiz time, Okay,
so I
let's
go to
start.
the first question?
Yes. So get ready to answer fast and get more points.
Ready?
Okay. So maybe I might have had some trouble with my Gitpod, maybe. Okay. Rugs, did we skip question 1?
I did not. It's going back in the same loop, which is surprising.
Okay. So
Let me try something different.
okay.
The countdown is working, and then it seems to go back in the same loop.
Okay.
We haven't seen this before, right?
I have. Yeah, put the generation ID on the questions. So I'm not sure what's happening.
Yes.
Oh, too bad.
All right, let me try this. Let me get out of this more and see if I can try a different way. Okay, so let's see this. Is this working?
Yeah, but I think...
Did I miss some?
Yeah, now we are seeing it, but I think many of the attendees already saw So they jumped to several questions ahead. So let's see where we are. So this is question number, I cannot say I remember by heart. So it's probably, Okay, so what's happening in this streaming? Okay, Rugs, you might want to do a hard reload of Menti and we start all over, maybe. That could be the best thing to do. So do a hard reload and we will play the game again. I mean, we still have time to, so it should not be a problem.
I can do that.
Okay, sorry guys, we will try again. Maybe, maybe the
hard
quiz
loading.
might have had some glitches.
Yeah, so you want me to log out and log in?
Yeah, but you probably have to, you have to, oh wait, click on reset results on the left, on the blue panel on the left. Reset, no, below, yeah.
Okay.
Reset everything, so we start fresh, otherwise, all slides. No.
No, I'm not doing it. Yeah, okay, all slides.
All slides, so we reset every input that we got and we start fresh.
Perfect.
Yeah, on live things, it happens. Thank you for understanding.
Yeah, exactly. Yes. Okay. So I'm going to present.
Okay, so you should, now it should work. You can,
If you're already logged in, I think
you will
should
have to join again. Sorry, guys. We will give you the link again and we will do it all over, no problem. With the, added advantage that already the questions. So
you know the questions and
but that's good because our goal is none other than to have to go home with some more knowledge about what's going on with messaging systems.
Exactly.
So if you learn the questions by heart, then that means we did our job.
Yes, and one more thing is, even though you know the answer, like I know the answer for some of these Menti, it still takes, you need to be nimble to be able to do that, right? And I can't do that. So it's still a question of your dexterity and how fast you're going to be.
Yeah.
So don't take anything for granted.
Okay.
That's what I'm saying.
Okay, so let's give.
So need the code again? Yeah.
Okay, so if you want to show the QR code, yes, it's the I key. Very good.
Yeah.
Yeah, David, sorry about that. I know it's been a bit of a problem today with Menti. We try again, and then we'll see how it works. Yeah. Okay, thank you, Nightbot. Okay, you're back to Mentimeter. Okay, so I think we can start and we try to, award, or you can just press forward arrow here.
Yeah, I don't think that we need to do that, right? Or did you know messaging platforms? We can skip it.
You now know. So the answer now is you are all experts. You are all very super mega experts. So no problem. No point in asking you, right? Yeah.
Oh, still people are saying no.
Come on.
All right.
So quiz time. Now, you should just have to hit enter and forward arrow when instructed. Right. That should be. So unless Menti has really some problems today, who knows? Okay, so
that is good.
Fingers crossed. Okay, so try just to press enter. Hopefully, yes. Okay.
Yep.
So first question. The database we created today is called AstraDB, is in the cloud, is called workshops or database. What database? Let's see. There is a bit. Think about what we did, what you did. And time's up. Aha. So we did not create any database today. And this was a tricky question because those of you who attended previous workshops know that we always use a database, but today we just use messaging. Yeah, okay.
Yes. I mean, I think the message here is that, I think databases are equally as important as streaming. They are really at the infrastructure level, right? Yeah, although we didn't create a database, it's very unlikely that you can write an application without a database. This was just a workshop, so just for fun.
Yeah. Okay. So next question.
Moving on, let's see the leaderboard, right?
Yeah. So Justioff on top, Chase and Kaniki, but still everything can happen. So let's move to second question.
Yeah.
Should be, yeah. Question number 2. If you press enter, okay. So remember, you have to be correct and fast. Today, we use the messaging pattern called PubSub, shared queue, failover, or exclusive. I think this we mentioned a few times, so let's see, think about that and be fast.
Nice.
Oh, that's very good. So yes, basically it's a fan out. Every message is going to every client that's subscribed, and that's rightly so because it's a game and every client has to display the same word coming from all updates that every other client sends out. So yes, very good.
Yeah.
Well done, guys.
Is failover and exclusive a messaging pattern? I don't think so.
Well,
right?
they are they are specific to Pulsar. They are variations of a messaging pattern of a basic message. So they are different kinds of subscriptions actually that you can have within Pulsar. Those of you who are interested, the Pulsar documentation is very complete and it's a fun read actually because it is very well done. So and there are a lot of cool features of Pulsar are described. So if you are interested in messaging platforms, please have a look. Okay, so let's move on.
Moving on. Let's see the leaderboard.
And who was the fastest? I think Mario maybe.
Just the
fastest again. Congratulations. You now start to have a position to defend.
He or she is like a bunny.
Yeah. Yeah. So, yeah, next question. Let's see.
Next question. Question 3. Get ready.
So, messaging platforms. They cannot be in the cloud. They decouple sender and receiver. They are always schemaless, or they are for data in motion. Now think a bit. We covered pretty extensively the general features of messaging platforms at the beginning. And both answers were good. And congratulations. Yeah. Very good, very good.
Nice. Let's see the leaderboard.
So I think we did a pretty good job today at conveying the right information, the correct, important bits of information. Let's see. I think the fastest was Taz, who also Carbs jumps to first position. Oh, X-Equoc with Ben X. Okay, third position Wiley. But Justioff is right behind the corner.
Justioff could jump back in.
Yeah, and everything can still happen. So don't lose your concentration, and let's move to the next question.
Next question. 4 of 7. We still got like almost half left, right?
Yeah, more than half.
Yes.
And data reaches the clients directly through Astra Streaming or through WebSockets or with client-initiated requests. Or is it maybe that the client only sends data and does not receive? Let's see. Let's see. Did you pay attention? Time's up.
Right?
Let's see. Through WebSockets. Very good. Yes. So there is an API between the client and the Astra Streaming topics. So yes, let's have a look at the leaderboard.
Let's have a look at the leaderboard. I think it would be changed. Maybe not.
Yeah, well, we have a fastest one.
Wiley jumps to top.
Wiley jumps to top, yes. Yeah, but it's really a close call, so
it's really close.
Everything can
like
still
between
happen.
one,
Let's see.
yeah, between 1 and 4, it's less than 50 points. So it could happen. So
Let me remind you that the first 3 will get some prizes. No pressure. Okay, so let's
all right,
see
move on.
what comes next.
Yes, 5 or 7.
Number 5. We introduced the generation in messages to know which client writes them, or to have a unique ID for storing them, or just for better debugging, or to ignore old updates. So there was a precise reason that led us to discuss the generation number in the messages, and that was time's up.
Oh, this got spread all over.
Okay, so yeah, the correct one is the last one. We need to introduce a generation number in messages to be able to clearly tell apart the old messages bouncing back from the server, from the topic and the server, and ignore them to avoid, this nasty, spurious loop of updates. Okay, yeah, that was tricky.
That was a tricky one.
It's good to know.
To know which client writes them, you would probably use a client ID or something, right?
Yeah, there is a client ID. So the client does not explicitly put a client ID in the messages, but this is added by the API because every WebSocket connection implies having a different client ID. So yeah, let's see.
Let's see how the leaderboard is shaping up. It's getting...
Oh, big changes. Yeah.
Big changes, indeed.
And Carbs jumps on top. Yeah, Chase Dudorino. So the leaderboard is changed a lot.
Oh, yeah. This is a significant upheaval.
Oh, right? Yeah.
All right,
who knows what happens in the next questions?
Exactly. There's still hope.
Yeah.
6 or 7. 2 more.
2 more. Answer fast. Chat data and player position data use different streaming topics. Oh, there's a typo.
Typo?
My fault. Or they use the same streaming topic, or maybe it depends. I always want to have typo-free material, but yeah, sometimes. Let's see. Chat data and player position data, yes, they use the same streaming topic. Very good. One thing that we said is that in a, say, production grade kind of application, we probably want to use different topics, which might have also different retention policies or whatever. Yeah, Greg. No swag for you. Okay, so let's see what happened in the leaderboard.
Let's check the leaderboard now.
Let's see. Yeah, okay, most of the answers were correct here. And okay, no big changes at the top. So
I don't think there's much change, right? Yeah, no. Let's see. The last question for all the marbles.
Yes,
here it goes.
Let's see.
Right. 7 of 7. Answer fast.
Answer fast and correct. In this game, some messages never go through Astra Streaming. True or false? Dun, 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 dun.
Ta-da!
And the time is up. Let's see. And the answer is, it's true.
You managed to get
you remember we mentioned these geometry updates. So when a new connection, a new WebSocket is established from a new client, the server, the API, just tells the client, oh, the game word is going to be this and this. And this does not need to go through Astra Streaming because it is never broadcast. Yeah, that was hard. Indeed, it was the last one. I'm sorry, Giuliano, next time. Better luck next time. Let's have a look at the final leaderboard then.
Final leaderboard, I'm sure there are going to be a lot of changes here, right?
Yeah, probably.
Right, so,
oh, and but
let's
still,
see.
BenX jumps on top. Okay, congratulations, Carbs, BenX, and Chase, and please. So Rags, you should not touch your Menti at all because
No, yeah, I'm keeping it.
leave it like that. Leave it like that, like this, and let me do this because the first three should take a screenshot of their winning screen and send that by email to the address you see. So let me retrieve my, I don't know where it is, so cannot see it, but send, let me write it in chat. Send your Menti winning screenshot to jack.fryer@datastacks.com. Okay, so.
And do you want to show the Menti screen again so that, people can take
well, they should be seeing them in their phone. So, okay, so.
On the phone set. Okay.
Anyway, the winner are Carbs, BenX, and Chase. So the first three. Okay. So we can leave Menti on, so you have plenty of time to take. So swag is, I'm actually not sure. It's probably there is a T-shirt, but I don't know because we change from time to time. So I'm not sure exactly what is the swag today. If you are among the winners, you will find out, and then maybe you will tell us. But
and the nice thing is we are able to mail it to anywhere in the world, right? Except if
I don't know exactly how is now the logistics working. But I think Jack Fryer will be the right person to ask. Now, very quickly, the homework.
Yeah,
you've been
Nikki
playing.
Is asking,
sorry,
Nikki has a good question.
Yeah,
Can I get a free pen for 13th place?
Come on, for the 13th place, you got a lot of knowledge for free. Isn't that a cool thing? Come on. Exactly. Okay. Anyway, homework. As Veronica remarked, will require you to do some coding. So to inspect the code, see how it works, and tweak it, because we want you to change the client so that the color of the name of the spiders reflects the spider color, as you see here. And not only that, but we also want you to change the API so that when a new client connects, they will get a nice welcome message in the chat. So you will find.
Stefano, do we want to remind our attendees that our homework submission process has changed and made it?
Yes. So homework submission process changed in the last weeks, and everything is there in the README for you to look at and to do. But basically, there will be a Google form. You will have to insert your data to your name and email because we want to award you a badge. Then there are some questions to answer. There is some upload to do of your screenshot of your application after the homework. Then don't forget to click submit. And then if everything works, you will get your nice badge. So almost last thing, we run workshops every week. So be sure to connect with us on datastacks.com/workshops because we always run cool workshops on several topics ranging from databases to application development and whatnot. So that's important. And maybe don't forget to subscribe to our YouTube channel. And there is the lottery. So you have time until Thanksgiving to submit your, so enter the lottery with your material and get chances to win. You remember the Amazon gift cards. Next Monday and next Wednesday, there will be other events. So in particular, there is one about Java Spring application. The next one will be build a vast digital library, and that is based on the Jamstack with Node and Netlify serverless functions. That's very cool. La Marche It's good. It's very heartwarming to see what you're reading and to read what you're writing. Sorry, and it will be a pleasure to have you next time. So please join us. And another point is that we have a Discord channel that is going to be. So those of you who know us already, be aware that we are going to restyle. So there is a restyling of our Discord channel in progress. And probably, as far as I know, the new server will be launched tomorrow with a new name, a massive reorganization with the same purpose, but an even bigger mission. There will be more channels specific to several topics, and there will be prizes for newcomers and more and more and more. So if you already are on Discord, you just wait, sit back and enjoy the changes. If you're new, then you can reach us on dtsx.io/discord. So maybe I can ask Git the Nightbot to tell us this link. So please join us on Discord. And I think that's more or less all. So we thank you so much for attending until now. Sorry for running a bit late. We had this Menti glitch. Don't forget to subscribe to our YouTube channel. And for me, that's all. It was nice to do this with you. I hope it's been fun for you as well. Spiders, everyone. Let me just show you one thing. I have a stone here with a spider painted on it, just to say, when I say I like spiders, I mean that. And that's it for me. So see you next time.
Thanks, everyone.
And goodbye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
In a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.